All right, let's face it. Get into the world of CNC machines can feel a bit like walking onto a factory floor where everyone's talking in some kind of code language.
Hmm.
You hear terms like CNC milling machine, then you hear machining center. And you're kind of left thinking, what's the deal? What's the real difference here? And why should I even care?
Yeah, I get that. It can definitely feel like a bit of a maze out there, for anyone who's really looking to take their manufacturing capabilities to the next level, whether that's, tackling more intricate designs or just bumping up the sheer volume of what they can produce. Understanding that distinction is really critical. It's not just jargon.
It's not. Not at all.
Yeah.
So that's exactly what we're going to do today. We're taking a deep dive. We're going to try to cut through some of that fog, lay out the core differences between those two machine types, and really explore why that matters for the kind of work that, you, the listener, might be doing. And then we'll even get into the nitty-gritty of automatic tool changers, the tech behind them. We've got some great resources that really make things clear,
Yeah.
especially all the clever ways machining centers handle their tooling.
Yeah, some really interesting stuff in there.
So let's jump right in.
Okay, so the fundamental difference between a standard CNC milling machine and a CNC machining center, it boils down to one key feature, and that's the presence of an automatic tool changer, or ATC for short, and of course, the tool magazine that goes along with it.
That's really the heart of the matter, right? The machining center has this built-in ability to swap tools on its own during operation, all programmed in beforehand. Nobody has to physically go and do anything. And that's all thanks to the ATC and this tool magazine, which is basically like a library of different tools standing by, ready for action.
Right, exactly. Now, on a standard CNC milling machine, those tool changes, they're manual. So someone actually has to stop the machine mid-cycle, physically swap out the tools based on what the program calls for.
And that one difference, seemingly simple, it really has a ripple effect when it comes to automation. Because a machining center can automatically go between a whole range of tools, drills, taps, different sizes and types of milling cutters. It can perform multiple machining operations all in one setup, like a multitasking master.
Perfect way to put it. Yeah, and for you, the listener, if you're working on parts that require a number of different tools to complete, a machining center can really, really ramp up your productivity. Just because those automated tool changes, they happen so quickly. We're talking mere seconds.
That's where it gets interesting if you're focused on efficiency. That speed and automation allows for much more complex parts to be machined, and efficiently. On the flip side, you might have a standard milling machine, and that might be perfectly suitable for simpler jobs, or situations where you're only changing tools very infrequently.
Right, right. It's all about the right tool for the job, as they say. Now, once you start thinking about machining centers, a question that naturally comes up is, well, how many tools can these things actually hold? It sounds like it could be a lot.
It does. Yeah, and the answer, like with so many things, is it depends. There's a real range. You can have something with like 10 tools on the smaller end, up to over 200 on the bigger, more sophisticated machines.
That's a pretty significant span. What determines how many tools a machine can handle? What are the driving factors?
There's a few things that come into play. The physical size of the machine itself. Obviously, a larger machine is going to have more space to accommodate a bigger tool magazine. And then the intended use is another factor. Are you making basic shapes just using a handful of tools? Or are we talking about very intricate components that need a whole arsenal of specialized cutters? And then you've also got the specific design of the tool magazine system itself. That plays a role.
You mentioned different types of magazines earlier. What are the main categories we should be aware of?
Okay, so the most common types you'll see are hat type, sometimes called umbrella type. We talked about that before, disc type, and then chain type.
Okay, so let's break them down. Let's start with the hat type or umbrella type. What's the story with those?
All right, so those are often found on smaller vertical machining centers, or VMCs. That's where the main spindle points vertically. Hat-type magazines, they're known for being pretty straightforward, reliable, pretty simple operation. So you're gaining simplicity and lower cost for basic tasks, but you're giving up some speed and the capacity to handle a ton of different tools.
Got it. So what kind of limitations are we talking about with this simpler design?
Well, for one, the tool changes tend to be a bit slower, maybe in that like 4 to 6 second range. And the capacity is usually lower, around 16 to 24 tools. The sources we looked at, they really highlighted that they're best suited for simpler parts or, smaller production runs.
Makes sense. Simpler design, more basic applications. What about disc-type magazines? What sets those apart?
So disc type, sometimes called arm type or manipulator magazines, they're a step up, both in speed and capacity. These systems actually use a mechanical arm to physically grab and swap the tools.
Ah, so that's where you get those cool robotic arms zipping around inside the machine.
Exactly. And because you have that dedicated arm, the tool changes are a lot faster. And they can handle more tools too, often something like 24 to 60, even more.
So a good balance between capacity and complexity. What are the trade-offs with this type, though?
You're looking at a higher price tag compared to the hat type systems. And there might be some limitations on, like, the maximum weight or length of the tools they can handle. But for a shop that needs a wider variety of tools and wants to keep those turnaround times fast, they're a popular choice.
Makes sense. And then we've got the heavy hitters, the chain-type magazines. What makes them unique?
These are the workhorses. When it comes to sheer tool storage, they're the kings. You typically find them on larger horizontal machining centers, HMCs where the spindle's horizontal, or on big vertical machines that just need a huge number of tools available.
So we're talking serious tool capacity here.
Oh yeah, capacities easily reach 100, 120, even over 200 tools. This kind of capacity is a must for machining really complex components, like, the stuff you'd see in aerospace, or for running long production cycles where you don't want to be babysitting the machine.
That level of automation is impressive. But there's got to be a trade-off somewhere. What's the catch with these high-capacity systems?
Well, the mechanics are more intricate, right? So there's a chance you're looking at more maintenance down the line. It's worth thinking about that managing and maintaining that many tools, it becomes a whole other task in itself.
Yeah, that's a good point. It's not just plug and play. Now, the sources we looked at actually had a helpful table. They linked machine size, tool capacity, and then typical applications. It's a good way to visualize the different needs. For instance, a small vertical machine, 10 to 24 tools, that's perfect for simpler parts training purposes, lower cost, simpler mechanics.
Exactly. And then you step up to a medium-sized vertical or horizontal machine, 24 to 60 tools. That's that sweet spot for a lot of job shops. Need some flexibility, but not ready to make a huge investment.
Right. And then those large machines packed with 60 to over 200 tools, those are for your highly complex jobs. Aerospace, mold making, where the increase in productivity is worth that higher investment and that extra complexity.
They even mentioned that a popular machine, the Haas VF2, it often comes with a 30 tool changer. Puts it right in that middle category.
Oh, yeah, a good example. And it highlights the trade-off. More tools means less time spent changing them. You can tackle more intricate parts in a single setup, but you're paying more, and it is more complex machinery.
Makes you think. When you're looking at tool capacity, it's not just about your current projects, it's about where you see your needs going in the future.
Yeah, future-proofing. Thinking about potential future part complexity, that's key for making the right investment today. Now, okay, so we've got these magazines full of tools, but how does the machine actually do that automated swap? It sounds almost magical.
It's kind of mind-blowing when you see it in action. So CNC Machining Centers, they use this ATC system, and it's usually triggered by a specific command in the program, often a MO6 code.
All right, and then what happens? Walk me through it.
So basically, the magazine, it rotates or moves to present the right tool to the changer mechanism. Then that mechanism, whether it's a robotic arm or some other system, it grabs both the new tool from the magazine and the old tool that's in the spindle at the same time. Then really quickly, it swaps them, and the new tool gets clamped into the spindle.
Like a perfectly choreographed dance. We talked about those different methods for this swap, like the robotic arm systems that are common with disc-type magazines. How does that work in the real world?
Okay, so with a robotic arm system, you've got this dedicated mechanical arm, and it's moving with incredible speed and precision. Often it'll pick up the next tool almost at the same time as pulling the current tool out of the spindle. Then a quick rotary motion or a linear motion, it swaps their positions. Imagine like a skilled juggler quickly exchanging items in midair.
So a near simultaneous exchange, that's got to be super efficient.
Exactly. It results in really short chip-to-tip times. Remember, that's the time from when the last cut with the old tool ends to when the first cut with the new tool starts. Often it's less than 2 seconds. Some of the really high-end synchronous systems, they can get it under a second. That really cuts down on the time the machine's just sitting there, not cutting material.
Now, as we mentioned before, those systems, they do tend to be more complex mechanically, can be pricier to buy and maintain.
That's the trade-off. You're usually going to see them in high production environments where, every fraction of a second counts. Every little bit you can shave off that machining cycle time is important.
Makes sense. What about direct tool changing, often used with those hat-type magazines? That seems like a different approach.
Yeah, direct tool changing, it's more of a direct interaction between the spindle head and the tool magazine. There are a couple ways it's done. In one, the magazine moves towards the spindle, lines up the right tool pocket, and then the spindle moves vertically to pick up the tool or drop one off. Then the magazine moves back.
Okay, and the other way.
The spindle head moves over to a fixed spot where the magazine is and does the exchange there.
So no separate robotic arm doing the fancy moves. What are the pros and cons of this method?
Well, the big pluses are it's a simpler design overall and potentially cheaper upfront. The downside is the tool change cycles are usually slower compared to the robotic arm.
So you'd see this on like entry-level VMCs or maybe older machines where speed wasn't the absolute top priority.
Right, exactly.
And then we had turret head tool changing. That sounded like a completely different beast.
It is a bit different. So with this setup, the tools aren't in a separate magazine. They're mounted right onto a rotating turret. To change tools, the whole turret just rotates, brings the right tool into position.
Wow, that's got to be lightning fast. No separate arm or magazine movement.
It's super fast. The tool change time is basically just the time it takes for the turret to index to rotate to the next tool. And it makes for a very compact machine.
So what are the limitations of a turret system then?
The main one is how many tools you can have at the ready. Since they're mounted right on the turret, the capacity is usually lower compared to a magazine system. But it's great for, like, multitasking lathes, Swiss-type machines, certain production machines where you don't always need a huge variety of tools for a single part.
So in the end, they all do automated tool changing, but the speed and the mechanical complexity, it can vary a lot. Depends on the design.
Absolutely. We've talked about how some of these tool changes can be lightning fast. But what about when things start to slow down? That can really eat into your production time, can't it? And that affects your bottom line.
Yeah, no doubt. Slower tool changes, it means more time the machine's not actually cutting. That affects your efficiency, how many parts you can make, your costs. That's why chip-to-chip time is such a big deal in machining.
So what are some of the main culprits behind those slow tool changes?
There are a few things. We already talked about the basic mechanical design, right?
Yeah.
An arm type changer is inherently faster than a direct type. But there are other factors too.
What else should we be thinking about?
Spindle orientation time. Before the tool can be changed, the spindle has to stop in a specific position, so the tool gripping mechanism can engage properly. This can take anywhere from 1 to 5 seconds, depending on the machine.
Might not seem like much, but it adds up over hundreds or thousands of tool changes.
It does. And then you've got the distance the machine components have to travel. If the spindle or the magazine needs to move a lot during the tool change, that takes time. You notice this on bigger machines, especially vertical ones, where the spindle might have to move a lot in the Z-axis to get out of the way of the workpiece.
So those are more about the machine's design and its movements. What about the tools themselves? Can their condition affect how fast they're changed?
Absolutely. The condition of the tools and their holders is critical. Worn or damaged pull, studs, those little knobs on tool holders, any dirt or damage in the taper of the holder or the spindle that can prevent smooth clamping and release. That leads to hesitations, errors, even manual intervention. Stops production completely. Keeping those tapers spotless, that's vital. I've seen tiny bits of contamination cause major headaches.
What about a tool getting stuck, seized up in the spindle? That sounds scary.
It's a big problem. Can happen if you over-tighten the tool, if the tapers are damaged, or if there's contamination. When a tool gets stuck, the machine stops. You might have to use force to remove it, and that risks damaging both the tool and the spindle. I remember one time a tool was so seized we spent hours with a special puller trying to get it out. Costly delay.
Wow. So, beyond the mechanics and the tool condition, are there operational things that can affect tool change times?
Yeah, how you program the machine and how well you maintain it matters. If your program isn't efficient with tool management, maybe making unnecessary changes or not having commonly used tools in easy-to-reach spots, that adds time. And the machine's settings and its overall maintenance are important too. The parameters that control the tool changer's speed, those can be adjusted, maybe slowed down for safety during setup. But if you forget to reset them to the optimal speed, that'll impact production. And poor maintenance, like low air pressure for the actuators or worn guide rails for the changer arm, that'll make things slow and unreliable.
The sources we looked at, they had a really good summary table that listed all these factors and how they affect things. It's a good reminder that it's not just about how fast the arm moves.
Yeah, it's the whole package. The inherent speed of the ATC, the necessary steps like spindle orientation and travel, the condition of your tools, and even how well you maintain and program the machine. To avoid delays, you need smart programming, consistent maintenance, and careful operation.
Okay, this is all making a lot of sense. Now, thinking about that tool magazine, holding all those expensive tools, all those complex mechanisms, it's not just a passive storage unit, is it? It must need a fair bit of care and attention.
You're absolutely right. The tool magazine, it's a critical part of the machining center, and it's active, not passive. If you neglect its maintenance, you're asking for trouble. It's not just load them up and forget about them.
So regular maintenance is a must, absolutely essential.
Yeah, there's no way around it. The magazine and the whole ATC system are complicated. Motors, sensors, chains, gears, robotic arms, pneumatic or hydraulic actuators. Everything needs to be perfectly aligned with the spindle. Keeping it clean, lubricated, aligned, adjusted, all of that is crucial for reliable, fast, and accurate tool changes.
What happens if you skip maintenance? What are the risks?
Well, a lot of things. First, reliability. Maintenance prevents jams in the magazine, tools being dropped which can be dangerous and mess up your work, and missed tool changes that just stop production. Imagine having to scrap a part because a tool wasn't loaded right.
Not a good day at the shop.
Nope. And then there's accuracy. A poorly maintained magazine can mean tools aren't seated properly in the spindle. That causes vibration, bad surface finishes, wrong dimensions, even damage to the tool or the spindle itself. And then there's the lifespan of your equipment. Regular upkeep reduces wear and tear on expensive parts, like the changer arm, the indexing mechanisms, bearings, drive systems. Preventative care is always cheaper than replacing major parts. And lastly, good maintenance keeps those tool changes fast and consistent. Things run smoothly, the sensors work right.
So it's about avoiding breakdowns, keeping your work high quality, making your machine last longer, and just operating efficiently. What does a typical maintenance schedule look like for a tool magazine?
You always want to check your machine's manual. Every machine's different, but generally there are daily checks that the operator does, visual inspection for damage, loose parts, chip buildup, cleaning, like wiping surfaces and using air to blow away chips, and checking air pressure.
What about the checks that aren't done daily?
Weekly checks are often shared between the operator and maintenance. Lubrication, checking levels, greasing points, cleaning the tool pockets in the magazine, checking chain tension if you've got a chain-type magazine.
What about monthly?
That's usually for the maintenance team. They'll test the sensors, make sure they're working right, clean or replace air filters in the pneumatic lines, and do a basic check of the alignment between the changer arm, the magazine, and the spindle.
And then the big stuff that's done less often.
Yeah, annually or semi-annually, you'll probably bring in a technician. They'll do a detailed inspection for wear, check the alignment with precision tools, make adjustments, replace worn parts like seals and wipers, and do a full lubrication service.
The sources we looked at, they pointed out that if you're machining abrasive materials, like some kinds of cast iron, you might need to clean more often than a standard schedule.
That's important. Different materials and processes have different demands. High-volume, continuous operation might need more frequent checks of bearings and other parts. Always check your machine's manual. It's your go-to guide.
So the tool magazine, it's not just a place to put tools. It's a vital part of the machining center. It needs consistent care to keep things running smoothly.
100%. If you ignore maintenance, you're going to have headaches, expensive repairs, and lost production time. Not worth it.
Well, this has been a really insightful deep dive. It's clear that the automatic tool changer is what really sets apart CNC milling machines and machining centers. It unlocks all sorts of automated possibilities.
For sure. It's important to understand tool magazine capacity, the different tool changing mechanisms, what affects their speed, and how crucial maintenance is. All of that helps you choose the right machine and run it effectively.
You know, it makes you think. All this intricate automation and precision in something as seemingly simple as changing tools. What other industrial processes, things we take for granted, have all this hidden complexity behind them?
Yeah, a good question. There's a lot of clever engineering quietly at work all around us.
Thanks for joining us for this deep dive. Until next time.